So let's take a look at some examples of how to do the inequalities algebraically. So you would solve these normally. You just ignore the inequality, act like it's not there, pretend like it's an equal sign, and we'll analyze the inequality later, just like we do with the graphs. We made the graphs, then we analyze the inequality. So let's do that with this. We are going to, this has no bx term, so the process for that is the square root method. So we will reverse the order of operations, starting with addition and subtraction. Here we go. 13 plus 3 is 16. Then we divide by 2. So you can see that's just a very easy process that at this point, after solving quadratics already, we sort of have mastered this. And again, just ignore that inequality. I got to be honest with you. I would prefer if at this stage you just don't even write it down. Okay, I know that seems weird to put an equal sign right here, but you're trying to see where this solution is valid. So that does not mean you use an inequality yet. All right, so here we have a plus or a minus, and then we got to break down the 8, just like we learned in Algebra 1 and Geometry and this year. So 8 using a perfect factor, using a prime factor tree is this, and that would be 2 square root of 2. So we're going to have plus or minus 2 square root of 2. So the question is, what is the answer that will create this domain? So let's take a look at a number line analysis. And this is the first time you've probably ever seen this. And what we're doing is we're going to put these on a number line. We're going to put the first answer at negative 2 square root of 2, just knowing that it's basically smaller than 0. And this one being 2 square root of 2. And what we're going to try to do is we're going to check to see where this inequality is valid. So what I do is I don't have to use this number. This is where it is equal. These are the balance points. So the question is, where is it less than? That's what we're trying to examine. So I can pick anything I want that's smaller than negative 2. Why don't we pick a nice number, negative 2 root 2. We're going to pick a nice number, like we're going to check x equals negative 10. That's super easy to work with. And what we're going to do is we're going to put that number into the inequality and see what happens. So if I put negative 10 into here, okay, and I subtract 3 from it, using the order of operations, this would be 100. This would be times 2. So this is 200 minus 3, or 197. And the question is the inequality valid for it being less than or equal to 13? That is false. So I put a big fat X. The inequality is invalid here. Then I pick an answer between negative 2 root 2 and root 2, which would be the obvious one there would be 0, because 0 is easy to work with, and I plug it into the inequality. So 2 times 0 squared minus 3, this whole thing would go to 0, so I have negative 3, and then I check the inequality. Is negative 3 less than 13? Again, I'm just going back to the original problem. This is saying the inequality is valid. So it's valid here. It's valid on the whole interval. If you check anything on the interval, it'll say it's true. I just picked the easiest one I could think of. So then we're going to pick x equals 10. So if I pick x equals 10, I actually get the same answer here, because when you square something, it becomes positive, but I'll show you. That doesn't always happen, so you want to actually work this out. So this would be 100 times 2, or 200 minus 3 is 197. And of course, that is an invalid solution for the inequality, because that is clearly not less than 13. So when you look at this picture, it's pretty evident the answer is here. And so we use this symbol here. So we're going to have a bracket, and the answer is valid between negative 2 root 2 and 2 root 2. So that this mathematical expression models exactly the picture you're seeing here. All right, let's try one more of those that actually factors. All right, so ignore the inequality. What would you do? Well, I have a bx term, so I'm going to balance this by moving everything to one side, creating a 0 on the other. And I wanted to maintain that the x squared term was positive, so now I have x squared. 4 minus 2 is positive 2. And then I have this negative 8. And again, I'm just going to ignore the inequality that is equals. So now we're going to factor this. You can use the reverse box method if you want to factor it. But when you have something like 8, you only have 2 factors, 1 times 8 and 2 times 4. And you need to subtract them to get 2. So it's pretty obvious that it's going to be x plus and x minus to get the subtraction. The 4 would want to be positive, and the 2 would want to be negative, because 4 minus 2 is 2, and 4 times negative 2 is negative 8. Then we use our zero product property, so x plus 4 is equal to 0. We subtract 4 on both sides, so we get x equals negative 4, and then x minus 2 equals 0, so we get x equals 2. And those answers go on the number line. So those are the solutions for equaling it. They are the points of balance for the equation. That's where the equation is. So these two answers would be where these are equal, not greater than. So what we do is we put them in here, and then we check to see everywhere. I don't want to check these points, because what it will do is it will tell me that it's equals. And I don't care about equalness. I care about greater than-ness in this problem. So I'm going to pick anything I want smaller than negative 4. I just like to use negative 10 if I can, because it's a nice, easy number to use. You could use negative 5. It doesn't really matter. I just like things that are by tens because they're easy to do in your brain and figure out. So let's get started. So if I take negative 10 and I square it, I would get 100. And then I would add 4 times negative 10. So that would be 100 minus 40, or 60. And then I actually, in this problem, have to check it also here. So let's see, 2 times negative 10 plus 8, that's going to be negative 20 plus 8, or negative 12. So the question is this a valid inequality? Yes, 60 is bigger than negative 12, so this is valid here. Again, I like to use 0 if I can. So over here, I'm just going to use 0, which is really easy to use in an equation. So I just get 0 squared plus 4 times 0. Very easy. That comes out to 0. And then I check it in the other side. So I have 2 times 0 plus 8. So that will give me 8. And then the question is the inequality valid? Is 0 bigger than 8? 0 is not bigger than 8. So not valid here. Then I pick something beyond 2. Again, big surprise. I'm going to pick 10. It's just an easy number to work with. So we have 10 squared, and then plus 4 times 10. That's going to give us 100 plus 40, or 140. And then for the other one, I have 2 times 10 plus 8, which is 28. And so the question is, using the inequality in the problem, we have a greater than sign. Is 140 greater than 28? It is. So now I have to describe this number line using the notation we know. I don't have this here, and this is negative infinity. It always helps to label your number line. So negative infinity, it stops being valid at 4. It then stops and then starts at 2 and goes to infinity. We know that we have to use parentheses for infinities. This does not have an equal sign, so I will use a parentheses here, and we know that we take two domains and connect them with the union symbol when there's more than one. All right, let's take a look at one more example. Okay, so here we go. Same idea here. In this problem, we're looking at it and we say to ourselves, okay, what do I want to do to solve it? Well, what I want to do is I'm going to move the 2x over because I don't want to get rid of my positive term there. I'm going to subtract my 1 over there. I'm going to set this equal to 0. So I have 2x squared plus 2x. Oh, sorry, I didn't pay attention. That's going to be minus x. Got to combine your like terms. So 2x squared, I got distracted by all that text, minus x, and then minus 1. And then we're going to factor that if we can. And remember, if you can't factor, you can always stop and use the discriminant if you need to. So here we go. We're going to try to factor it using the box method in reverse. Okay, and remember, if you just try this box method in reverse, I think you'll actually find factoring pretty easy. So this has to be 2x squared, and this has to be negative 1. Those are locked in. I've got to have this. I've got to have that. And so 1 only has factors of 1 times 1. So the things that are up for gamble are this. So this is 2x times x to get this. And then I have a 1 and a 1. So 2x goes here. X times 1 is x. I need to get a negative. So to get that negative, I need to put the negative on the 2, because when I combine these two like terms, that'll give me negative 2. So that means the negative needs to go fully out to there to produce the correct factors. So I have 0 is equal to x minus 1 and 2x plus 1. Remember, if you don't put anything on it, it's positive. And that negative, again, it comes from this row, because negative 1 times positive 1 is negative 1. So then I use a zero product property, x minus 1 equals 0, so x is equal to 1. And then 2x plus 1 is equal to 0, so 2x equals negative 1. Divide by 2, and you get x equals negative 1/2. So then we go and examine the number line at these points of balance. Do not put make sure you put them in order as well. You can't do this because that doesn't make sense on a number line. A number line is in ascending order. So you would want to make sure that you put negative 1/2 here and then put the 1 there. So again, fixed price, I'm going to pick x equals negative 10. And in this problem, I'm going to put negative 10 in here. So negative 2 times 10. And then plus 1, that's negative 20 plus 1, or negative 19. And it wants me to check if it's greater than or equal to plugging in negative 10 into 2 negative 10 squared minus 3 times negative 10. So that would be 100 times 2, or 200, and then plus, there are two negatives, so that'll be 230. So the question is negative 19 greater than 230? And the answer is no, it is not. So then we will try x equals 0. Okay, so here we go. We have negative 2 times 0 plus 1, which is 1. And if we plug it in the right side, we have 2 times 0 squared minus 3 times 0. Everything would cancel out there, giving us 0. We look at the inequality that they give us, which is greater than, and 1 is greater than 0. So correct in the middle. And then the next one, we're going to use 10. It'll be similar to the right, but not exactly the same. So let's make sure we look through it here. Negative 2 times 10 plus 1 is negative 19. That actually means I made a mistake here. So let's go back and look. So that would be a negative, and that would be 21. So it is still false, but that should have been 21. And if you saw that earlier, I'm glad you did. So it is supposed to be 20 plus 1, or 21, and 21 is not greater than 230, so that still is false. It's always good to do this other side, because sometimes you catch a mistake, as you just saw. So then I'll put the 10. I'll put 10 into the other side. So that's 2 times 10 squared minus 3 times 10. So that's 200 minus 30, or 170. And the question is, does this inequality hold? Is negative 19 greater than 170? The answer is false. So even though I made a mistake there, it still was false. And that's why it's important to do both the left and the right, because sometimes doing the right will help you notice if you made a mistake on the left. So then what I'm going to do is I'm going to identify this interval notation. It goes from negative 2 to 1. Okay, sorry, negative 1/2 to 1. And this is an equal sign, so I will be using brackets. All right, you might want to watch through that again and make sure you understand how to factor and how you understand how to use inequality. And I hope you enjoyed that video.